We're going to continue to talk about exponential functions here, but we're going to now start with the properties of an exponential function. So your exponential function, let me just refer to this one here. This is what your exponential function would look like if the base was greater than 1. So this is usually the function we show you to show you an exponential function. Alright, first of all, the domain of this function is all real numbers. So you can plug in any negative number, you can plug in any positive number into the function, and you'll get a real number solution. Now, of course, if you plug in a very, very small negative number like negative 1,000 or something like that, the solution might be so small it's negligible because it's going to be close to 0. And then if you plug in a real big number, then the y value is going to be so large that it might be ridiculous. But anyway, the domain's all real numbers. Now the range can be any number greater than 0. So technically you cannot get 0. You can get as close to 0 as you'd like, but you can't get 0. So it would be 0 up to infinity. So that would be the range. And all of these graphs that are in this form, a to the x, when x is 0, y would always be 1. So the graph has a y-intercept of 0, 1, and it never crosses or touches the x-axis. Now actually, even though this is not a rational function, but it does have an asymptote. This function has a horizontal asymptote, which is the y-axis, and the reason is because as x goes to negative infinity, the graph gets closer and closer and closer to this y-axis. Now if the base is less than 1, then you switch that around and say as x goes to positive infinity, the graph gets closer and closer and closer to the x-axis. I think I said y-axis here, it's x-axis actually. So the graph gets closer to the x-axis as x goes to infinity or negative infinity. So you have a horizontal asymptote. And then this right here just kind of shows you the difference between these two graphs. If a is greater than 1, like in this case, then the function is increasing as you go left to right. And if a is less than 1, then the function is decreasing as you go left to right. And then the other thing is if you do the horizontal line test on these functions, you'll see that both of these functions, no matter which one we're dealing with, they're 1 to 1, so therefore they have inverses. And we'll actually find that the inverse of these exponential functions are the log functions that we'll talk about a little bit later. So this video is going to be pretty short because, like I said, all I wanted to talk about here was the properties of the exponential functions. In the next video, I'll talk to you about a special exponential function that involves a special base where the base is the number e. So we'll talk about